My laboratory is focused on using techniques developed through biomolecular engineering and synthetic biology to engineer T cells for cancer therapy. What that means is we try to engineer white blood cells so that they can very effectively and specifically target tumor cells and try to kill them. And we do so by engineering synthetic proteins, for example, that would allow the T cells to recognize tumor cells and to distinguish them from other healthy cells in the same patient. And we also engineer other aspects of the T cells so that when they encounter these tumor cells, they can very effectively eliminate them by releasing various toxic chemicals, for example, that would trigger target cell death. Our focus has been on developing what we call platform technologies, meaning these should be adaptable for a wide variety of cancers. For now, we tend to use CD19, for example, which is an antigen present on blood tumors, so blood cancers such as B-cell leukemia and lymphoma, as our model system because it has worked very well in the clinic. However, the technology we're developing should be translatable to other cancers as well. Hi, my name is Yvonne Chen and I hope everyone is doing well. The video you just saw was recorded about 4 years ago, and I'm happy to report that we've made quite a bit of progress since then. As mentioned previously, my lab focuses on engineering T cells to target cancer, and we do so by producing chimeric antigen receptors, or CARs, that allow T cells to recognize tumor cells and kill them. Now, we were the first to report a bispecific CAR that can simultaneously recognize two different antigens called CD19 and CD20, which are found on the surface of B-cell lymphoma. And we have been able to carry this technology from initial molecular design in our laboratory all the way through to a clinical trial that opened here at UCLA in October of 2019. I'm happy to report that our first two patients had complete responses, and they remain in complete remission now for over 6 and 9 months respectively. And the trial continues to enroll, and I'm very appreciative of all of the hard work from our patients as well as our clinical team in support of this trial. Now, as mentioned in the previous video, we're really focusing on platform technologies that can apply to not just a single therapy, but can be broadly applicable to a variety of diseases. And we have indeed been able to utilize the experience that we built from our CD19, CD20 bispecific CAR project to the development of additional bispecific CARs for cancer therapy. To that end, we have developed a new bispecific CAR targeting BCMA and CS1 for multiple myeloma, and this project is now being funded by CIRM for the preparation of an investigational new drug application, so that we hope to open a clinical trial here at UCLA in 2022. And in addition to these blood cancers, we're also now focusing a lot of our energy on developing new therapies for the treatment of solid tumors, which account for over 90% of all cancer diagnoses and cancer deaths in the US every year. Now, to that end, our lab was the first to report a CAR that can respond not just to surface-bound antigens like CD19 and BCMA, but also to soluble antigens like TGF-beta. And what this now allows us to do is engineer T cells that can respond to environmental signals that's present in the surrounding of solid tumors. And that can help us develop more efficacious therapies against solid tumors that have built up these defense mechanisms that protect themselves from the immune system. So we're very excited about these new developments, and we look forward to bringing these new therapies developed in our research lab to the clinic. And I want to emphasize how critical it is to have funding support from CIRM in order to carry these technologies to our patients' bedside, because these trials are honestly extremely expensive and very complicated. And so without CIRM, it is really difficult to do these kinds of translational and clinical research, and I'm very grateful that we have this resource here in California to allow us to work on these exciting technologies and new therapies for patients.